Hello, this is Dong-Soo from the Applied Superconductivity Lab. Today we will learn about the magnet constant. Here is the overall contents of this lecture. The magnet constant is the magnetic field divided by the operating current. Throughout the lecture, we will cover how the characteristics of the magnet constant vary depending on the type of medium. The magnet constant in a linear medium is invariable, and in a nonlinear medium, it is variable. In the case of a superconductor with an air core, the magnet constant is variable. First, let us discuss the magnet constant's characteristics depending on the medium's properties. The graph on the right represents a BH curve. Materials with constant permeability, such as air, show a linear BH graph, as shown in red circle. Therefore, the magnetic field divided by the operating current remains constant. It is important to note that regardless of the operating current, the slope of the magnetic field graph remains constant with respect to the operating current. On the other hand, for mediums with nonlinear permeability characteristics, such as those depicted by the dotted green circles and solid pink circles on the right, particularly when including an iron core, the magnetic field does not increase linearly in the saturation region as the operating current increases. Therefore, it can be observed that the magnet constant does not increase linearly, which is variable. For the superconductor case, due to the presence of screening currents in superconductors, they can exhibit diamagnetism and become nonlinear even with an air core. First, we need to briefly define the screening current to understand this concept. The screening current is a current that flows within the superconductor and generates a flux density in the opposite direction to the externally applied field. Thus, the magnet constant does not remain constant because of the diamagnetism from screening currents. This variability in the magnet constant may significantly affect some magnet applications. In this lecture, we have covered that the magnet constant can remain constant or vary depending on the type of medium. Second, the magnet constant remains constant in materials with linear permeability, such as air. However, when materials with nonlinear permeability, such as iron core, are included, the magnet constant becomes nonlinear. Finally, superconductors exhibit a unique property where the magnet constant becomes nonlinear due to the diamagnetic characteristics of the screening currents, even in the presence of an air core.